All right, welcome back. Today we are going to be looking at finding scale, finding and using scale. All right, so we use scale a lot in real life whenever we are looking at drawings and models of real life objects. So for example, if you're building with Legos and it's done to scale, architects, when you build any sort of model and they say the scale of that, this is what we're talking about. So a scale drawing or model is used to represent an object that is too big or too small to be shown in its actual size. And the dimensions of the object on the scale drawing are proportional to the dimensions of the actual object. And that's what helps it look real, because if it wasn't drawn to scale and it wasn't proportional, something about it would look off. So the scale is simply the ratio of the size of the model to its actual size. So we have model to actual, if you want to think about it. A scale can have the same units or different units. So for example, right, if we're looking at a map, you might see something like 1 centimeter is equal to 5 kilometers, and that would be the scale for the map. And we can also use scale to find missing measures on a model or the actual objects by setting up a proportion. All right, so let's look at a couple of examples and we'll kind of go from there. So just like we did before, it's super important that we keep our proportions consistent. So when we're setting up our scale and trying to find missing sizes, we want to make sure that we're comparing like model to model and actual to actual. So the scale in a drawing for a new pool is 2 inches is equal to 7 feet. So I'm going to set that up as a ratio of 2 inches on the model is the same as 7 feet in real life. It's saying the length of the pool on the drawing is 10 inches. So once again, we're going to use that inches to inches. So since we put inches on the top, I'm going to put inches on the top here. And we are trying to find for the actual length of the pool. So that's where we're going to put our X. And just like we did before, we're going to go ahead and utilize those cross products. So I'm going to do 7 times 10 has to equal our other cross product, which is 2 times X. So 70 is equal to 2 X's. We divide both sides by 2. So 35 is equal to X. And in this case, it's feet because that's the dimension of our actual object. So our answer would be 35 feet. All right, so why don't you pause the video and try this one out on your own. All right, so in this situation, our scale is we have 1.5 inches is equal to 2 feet in real life. The living room is 18 feet long, so on this one, our 18 feet is going to go on the bottom, and our X is the length on the blueprint. Once again, we're going to use those cross products. So I have 1.5 or 1.5 times 18 has to equal our 2X. So 1.5 times 18 gives us a value of 27. And that's going to equal 2X. We're going to divide both sides by 2. And X is equal to 13.5. And if we think about in the context, that's the length on the blueprint. So 13.5 inches is our actual answer. And that will work for any of these first problems. So if you want to pause the video and you can kind of check these out on your own. Now, some of them might end up with weird decimals and stuff like that, and that's okay. You can just put the decimal answers, or if you want to convert them to a fraction, you can definitely do that as well. All right, so now that you've had some chance to practice with using scale to find missing measurements, we're going to look at a situation where you are actually determining the scale. And in this, what we're going to do, if we need to find the scale of a drawing or a model, we're going to write the ratio of the model to the actual length, just like we did before, because scale is always going to be model to actual. And then we want to make sure we simplify the ratio so that numerator is 1. So we want 1 of something on the model to equal whatever it is on the actual item. So essentially what we're going to do is divide the numerator and the denominator by the value that's the numerator. So this is what I mean. So our drawing length is 9 inches, and that's equivalent to 45 feet on the actual object. But we want to find the scale. So we want this 9 inches not to be 9 inches anymore. We want it to be 1 inch. So in order to turn that into 1 inch, I have to take 9 and divide it by 9 to get the 1. But if I divide the numerator by 9, because I want it to be equivalent, I'm also going to divide the denominator by 9. So 45 divided by 9 is 5, but our unit is going to stay the same. So since it was 9 inches is 45 feet, that's proportional to 1 inch being 5 feet. And if you think about it, we can check that with those cross products, because if I do 45 times 1, that's 45. And if I do 9 times 5, that's also 45. So we can see that they're proportional. So on our, we would say then that our scale is 1 inch is equal to 5 feet. And then that would be our scale. All right, why don't you pause the video and try number 12 on your own. All right, to make this easier, I'm going to convert the 6 2/5 to a decimal. So I'm going to make this 6.4 meters is the same as 120 kilometers. Since I want my model to be 1 meter, I'm going to divide by 6.4 in both the numerator and the denominator, and I end up with 18.75. So our scale, we can write it a couple ways. I could write that it's 1 meter is equal to 18.75 kilometers. Or we could say that 1 meter is equal to 18 3/4 kilometers, because that 0.75 is the same as 3/4. So when we're using scale to find missing measurements, we don't have to worry about changing it to a 1. We can just use whatever values are given. But when we want to find the scale, the big thing is that we always want that 1 in the numerator, right? So when we're finding scale, we want to get it kind of almost simplified so that the numerator is 1 or the first number is 1. All right, if you have any questions, please reach out.